All right, thank you so much for coming to my session. I'm super excited to talk about Nerfstudio, a modular open source framework for making Nerf development easy. So I'd like to start my talk today with this dream that we've collectively all had, which is to visit a virtual place in 3D. This might be a completely new scene that you've generated and edited, or it could be a memory that you are visiting from the past. Of course, this picture is from the Ready Player One movie written by Ernest Cline, and there's this world called Oasis where you can experience a wide range of virtual environment. Of course, we've also seen this in Holodeck, in Star Trek, and also in books like Harry Potter, where there is this idea of conceive where you can take your memory and then go visit in that world. And today I am here to say this is a sci-fi staple. And today I'm here to say that this is really becoming a reality. So today, if you want to visit San Francisco virtually, we actually have this 3D reconstruction of these famous places in San Francisco that you can actually explore virtually. Of course, these are not on headsets yet, but it's only a matter of time that we get these experiences on VR. These approaches are already real-time rendered on machines, and these approaches can render really photorealistic faces, as you can see here. And of course, in January 2022, NVIDIA released a really cool approach which allows you to train these approaches in real time, and you can interact with them as they're being trained. And we can also capture different time of day and different appearances that happen. And more recently, people have been using these representations to do completely unconditional generation of objects and scenes. So what are these things? You may have heard of NeRF, which came up in 2020, which was released at ECCV conference made by my colleagues at Berkeley and also at Google. So what is NeRF? I'm just going to use this really nice video from the original authors. How NeRF works is that to render every single pixel, it shoots a ray from that pixel. And then along this array, you're going to query a single point, and you can think of this as a particle in space. It has a point XYZ and a view direction that you're looking at, and you're going to ask this neural representation what the color and the density of each particle. I like to think of these as shiny particles because they tend to change the way they look. They have the ability to do this, and this is why actually it looks really nice. And after you query it, you compose it together using a classic approach of volumetric rendering to make an image. This whole approach is trained to reconstruct all of the training views that you've seen doing the same thing that we just discussed. And this enables you to train the neural network to get this representation from which you can render this particular scene. Okay, so before we get into it, let's discuss what is the problem that NeRF is solving, because I do think it's nice to add the background and the historical context. And for this, you might have heard of this idea called plenoptic function. Plenoptic function is a super exciting concept presented by Adelson and Bergen in 1991. And they had a really exciting question in mind, which is, what is the set of all things that we can ever see? And how could we actually capture this? And they devised this conceptual function whose input is 7-dimensional, XYZ, viewpoint, time, and lambda for wavelength that conceptually can model the entirety of our visual reality. So they didn't really talk about how to make this function, but if this function existed, you can query it and then render any view at any time, at any, a wavelength. It was a really fancy idea. And you might have heard of solutions like light field and LumiGraph, which are the previous iterations to NeRF that was trying to solve the approach of plenoptic function, like try to learn the plenoptic function. Now let's simplify this function by getting rid of time and wavelength and making it into a static world that outputs RGB numbers. And so then you get this 5-dimensional function. And at this point, if you're familiar with NeRF, you might be like, oh, that looks familiar because that looks like the function that the MLP takes inside NeRF, which is true. There's a subtle difference. So planoptic function actually models everything that comes into a single eye at any time and place. So this is why if you actually could query this, you can actually render any view from anywhere. Instead, NeRF achieves the same, but does it by, instead of modeling what comes into the eye, it actually models the particles in every single point in space and their color and radiance that is view dependent. And this enables you to really fly through the scene, unlike light fields or past approaches, and become a really flexible representation that actually has an underlying 3D representation. Okay, so this is NeRF. And each of these particles is again modeled by this function that takes in 5-dimensional things and outputs color and density. So this was quite a flexible approach. And not only that, very easy to optimize because the volumetric rendering was able to pass gradients really easily. Basically, it was very easy to use and a really simple idea. Because of this, there has been a huge explosion of NeRF research since 2020. There's many approaches that I have no time to really list all of them in this figure. There's already like 2,000 citations, and it can capture all these kinds of different lighting effects. It's HDR, faces, a generative model, scene. You can even stylize it. You can use it for humans, and you can try to model it for dynamics. And so all of these work was happening. And even though it's super exciting, everybody's writing these papers that's coming out a lot at the same time. And there wasn't any central repository to kind of summarize all of these exciting development. And I think it's really interesting to consider the timeline because so much has happened in this past 3 years. So let's look at this. So original NeRF was archived in March 2020, which is super nice because it's exactly 3 years from today. It was presented at October in ECCV 2020, but that's when we saw it on the internet. A year later, our lab and a couple of other labs have presented an approach to make it real time. Like original NeRF was very impractical. It took like 30 seconds to render a small 800 by 800 image. And then around January 22, there was fast training like methods like planoxels, direct voxel optimization, instant NGP, also TensorRF, and all these things. And then right after January, large scale NeRF like block NeRF and etc. came out. And so this was around the time where really after looking at instant NGP, we were like, oh, you know what? Maybe this is like a thing where you can actually use it to normal everyday people can actually use it and then experience it. Until then, some papers like Instant NGP and MIP NeRF 360 has done these unbounded scenes, but it was still very difficult to capture them myself. For example, if I wanted to make a NeRF, I'd have to send it to my students and they had to run through their own processing and it was difficult to view them. And Instant NGP was a super inspiring project for us, but it's also completely implemented in CUDA that made it very difficult to modify, and so we didn't necessarily want to develop there. And so around this time we were like, yeah, and this is about exactly a year ago, we started thinking about building this open source framework called Nerfstudio, and we released this in October 2023, and this is the March, so it's really been a year-long effort until this time. Okay, so this is Nerfstudio, led by many students, which I will describe in the end of this talk. The design goals of Nerfstudio was simple. First of all, we wanted to make it easy to use, most importantly. And by using, I mean you can use it on your own data, maybe just from your phone or drone or in many type of formats. It also should be easy to develop. If you're doing research, you wanted to do rapid prototyping, combine different ideas very quickly. And because so many papers are coming out, we also wanted to centralize somewhere where you can novice users or researchers can learn about NeRFs. And so those are our goals. And then this is the framework that we ended up in. So it's an end-to-end framework. So first we begin with these inputs. It can be mobile, captured, just a video, or also through these recent apps like Polycam or Record 3D that has that you can run on your phones with LiDAR support that allows you to skip running CalmUp, which can be kind of tedious to implement and run. That really makes it really streamlined. And then we implemented the underlying NeRF in a very modular way. And then another one of the big emphasis that we had was it's really important to have a real-time viewer. This was inspired by InstantNGP, and we really wanted to make it into a web viewer so that it's really easy to experience the scene in real life, because it's very important that you do visual debugging. And then lastly, we wanted to export it into various kinds of formats and support this. So it's really going all the way from data to final render in an end-to-end framework. Okay, so here is one of the visualizations of our viewer. It's like video games. You can use WASD keyboards, and then you can fly through the scene. You can also make keyframes, and this has really developed since we released and then make a smooth video. We try to come up with an interface that's easy, although this is also still quite a challenge in engineering, a lot of engineering work. But once you set up these cameras, you can render the final scene. And here is an example of our recent renders. And you can fly through this world and explore it. Okay, so that's easy to use. On the aspect of easy to develop, we really wanted to keep everything Pythonic and modular as much as possible. And one, I think, contribution that we've made is to really simplify the way of thinking about NeRFs by dividing into the sampling algorithm, the fields and encoders, which is the underlying neural representation, as well as finally the volumetric rendering. And we separate it into these three categories. And within each, we implement various kinds of options of each ones. So for example, these types of different sampling approaches, different types of fields that includes InstantNGP type approaches or Planoxo-like approaches, or everything in between. Also, we implemented this volumetric rendering, which you can actually render all sorts of things. Okay, and so that's how we have this modular baseline. And as a result, we really wanted to have an interactive NeRF that is default there that you can actually run. And so here is the original NeRF, but over 3 years, like lots of things have changed. And so what we have is NeRFacto, which is a model that we developed by combining ideas that are already present, but one that, because of this combination, enables to strike the right balance between performance and easy development. So in a more technical talk, I will walk these through more slowly, but let me just quickly walk through this. Because we're dealing with real data, it's very important that you actually handle appearance embedding or reason about the appearance, like exposure changes or lighting during the, changing time of day. Of course, we have the NeRF field, but that has to be fast. So we actually went with the InstantNGP like hash dictionary encoding with a tiny MLP. But that alone is actually not enough to make it really fast. And how you make it really fast is to skip all the regions that should be skipped. And InstantNGP has a solution that requires CUDA implementation. Here, nice thing is that we incorporated proposal sampling that was proposed in MIP NeRF 360, but using InstantNGP like tiny MLPs to implement it to strike the right balance. So it's like fast while being able to keep everything Python. Of course, the real world can be 360, so we also have scene contraction so that everything fits. And of course, in real world, the cameras might be very noisy, so you also optimize these cameras. And as the coloring on the right bottom shows, these are ideas all coming from different papers. And our approach, because it's very modular, you can easily combine them. Lastly, for learning, we also have this nice documentation that our group wrote, where you can actually learn about different types of, contraction over here and different types of NeRF approaches. We also have a very active Discord community that our development members are actively monitoring and engaging with people, and this is really very cool to see. I'm going to show many results from the users who've used Nerfstudio to make some results. Please join our community and ask any questions to get started. Okay, So another addition that we recently added is to export these NeRFs into not just videos, but also point cloud and traditional representations like meshes, on which you can actually do all kinds of traditional graphics, things like simulation and all sorts of things. We also added fun camera effects where you can change the focal length and do dolly zoom like situation. Since the release, we really improved the usability of Nerfstudio. We added Polycam, and then also most recently, we integrated reality capture, OpenSFM, and CurieEngine, and all of these things so that it's very easy to integrate it. We also have collab support in case you don't have a big GPUs to run this. This is also available. And here are some results that were captured by the members of the development community at Berkeley. And all of these are captured using casual, everyday devices. And here are some more. That is one of the early dev team working on the right top corner. And here I'd like to highlight all of the really cool reconstructions that people have made on the internet. So this was also captured using Nerfstudio. It looks really nice and crisp and clean. Here is another drone footage at Egypt, I assume. It's really cool. Here is more. Here's another one. This comes with a little chirping sound of a bird, which makes you feel like you're flying through this scene, which is super fun. I really like the music. These scenes, especially added with the music, sound really cool. Here's another capture of the Gothic choir in a church in Switzerland. And people are using it for all sorts of things. For example, in this one, capturing a car, maybe possibly for some kind of an ad, or it's just a cool scene, maybe going to Tahoe. And not only objects, but also humans. Okay, and so lastly, I want to emphasize this recent addition that we added to the repo, which is a VFX integration with Blender. And this was really led by this undergrad student called Cyrus Veka. And then he really single-handedly implemented all of this VFX integration so that you can do these super cool effects, like flying into seeing this the Sutter Tower through this portal. And how is this made? This is made by first making 2 captures of NeRFs as seen on the top and using the same camera path using our viewer. You can now port that camera path to Blender and then render the Blender scene like below using the same camera path. Now, then all you have to do is composite them using post-production approaches, which enables this type of super cool VFX effects. This is our office, BWW, right over there. And this is a super cool demo that Cyrus made by combining the office with these fun Lego animation. Since we released this, many people on the industry and the internet have also started using this. So for a scene like this, captured at night, which already looks really cool, you can use this Blender integration to generate this super fancy, fun scene that is really beautiful and a super cool effect. Here is another one with this point cloud deformation that looks super awesome. Okay, so that is Nerfstudio, and we would like to do a couple of shout outs to the libraries that that were central in developing our library. So this is Tyro, which makes the config system really easy to use, developed by one of the team members, Brent. And this is NeRFAC, And so if Nerfstudio is too much end-to-end for you, and maybe you're a PhD student or a researcher, and you just have your own custom input engines, and like you don't really want to, you know, convert everything into Nerfstudio, you can simply use NeRFac, which is a drop-in replacement that is much lighter version of Nerfstudio, of a much lighter version of NeRF implementation. This is also our backbone for the Instant NGP baseline for implementation. And more features are on the way. This is a teaser for one of the unconditional scene generation. And the nice thing is that we've developed this, we're doing more research on this, and so more research is coming. And so this is a quick teaser for one of the recent approaches that we are working on. We're given this input NeRF scene on the right. We can use language, specifically instructions, to change the scene, adding a mustache or making it a marble statue or turning him into Albert Einstein or this clown. And also a super exciting line of direction, which is to integrate semantics and language into these 3D scenes in a 3D consistent way so that you can actually search for these scenes using language. Okay, and more research is going to be worked on this approach. I'd like to really end this talk with a big thanks to the Nerfstudio team. It's a big team now. Many undergrads and master's students and also PhD students have volunteered their time since our release. The team is growing. If you're at Berkeley and interested, do solve some of the issues on GitHub and send us an email and we will consider. We're also consistently looking for serious developments, the collaborators who want to take, help us do PR. And so we really want this community to grow. Lastly, I want to highlight the initial team. So this was a team led by Matt Tansek, Ethan Weaver, and Yvonne Ng, who are the co-star authors of this project. They're my students in my lab, also followed by Rilong, Brent, and Justin, who are also PhD students. Terrence and Alex are master's students, and Jake and Kamyar, Abik, and David are undergrad students. Also Cyrus and Rohan, who's been doing a lot more recently. So here's, I really want to thank the team for putting a lot of efforts. Lastly, I really want to highlight Matt Tansek, who was also in the original author of NeRF, and who really is putting a lot of effort into this project. He's the one who accepts all of your PRs and really leads this entire effort. To develop Nerfstudio wasn't entirely an easy decision because it was a lot of engineering work. Matt, Ethan, and Yvonne, we didn't really publish papers in the time that we were working on this, but we're really happy that we've made this. And in particular, Matt is graduating. I was really fortunate to have Matt as one of my first students, and he's nothing but excellent, and he's currently on the market. This is a once-in-a-lifetime opportunity if you are industry looking for people to hire, really is. So please consider, or it's your opportunity. And thank you so much, and I'm looking forward to taking any questions.